Good morning. So I've been using R off and on for about 15 years, but usually as part of another project, part of a project written in other languages. And so my perspective on R is a little different than someone who starts and ends their day just using R. I'm usually more concerned with R as a part of something else. So I'll talk about how to mix R with other languages, how to call from R out to other languages, or how to use R from something else. So why R? Well, the biggest advantage to R is the libraries. There's tons of really useful libraries in R, and for that reason, a lot of people use R even if they don't really want to. Maybe they don't like the language per se, but they want to use the functionality of R. And I would also say that R is the de facto standard language for statistical research, but be a little careful when I say that. When I mean that, by that I mean research into statistics per se. If people are using statistics to do research in genetics or meteorology or something else, they may not be as likely to use R. But if you see a paper in a statistical journal with a new algorithm or new method or something, you're very likely to see code written in R. Python is sort of catching up to R or past R, depending on your perspective, for data science. I mean, there's a blurry line between data science and statistics, but people who call themselves statisticians are more likely to use R. People who call themselves data scientists are maybe more likely to use Python. As far as statistical languages go, R is a very nice language. If you're coming to R from, say, SAS, R is a fantastic language. If you're coming to R from something like Java or Python or another language like that, you may be a little disappointed. As Dennis Ritchie said about C, you could say the same thing about R, that it's quirky, flawed, and an enormous success. All right, and so why would you want to mix languages? Two different use cases. One is you're writing R code, but you want to improve the efficiency. So R can be very slow, especially for things like loops. It handles loops very slowly. And so you might want to take some hotspot in your code and rewrite it in C or something else that's more performant. Also with memory, R doesn't handle memory particularly well, and so you may run out of memory doing something in R where the same code rewritten in C or some C-like language might have plenty of memory. And the efficiency and the memory are actually closely related. A compiler expert that I knew used to work with that looked at making R more efficient said that R spends most of its time allocating and deallocating objects. So the memory management is deep down into R where it's hard to make that more efficient. So I'll assume for this talk that if you're calling from R out to something else, it's because you want to improve efficiency. And that if you're calling into R from another language, it's because you want R's functionality. Maybe you're not particularly concerned about efficiency, but you just want to do something that there's an R library for. All right. So I'll spend most of the talk talking about ways to interact with R. First, I'm just going to say a few things about R itself. As I mentioned, R can be pretty slow, and so you might want to optimize R, and I'll give you my personal algorithm for how to optimize R. First, vectorize. R is a vector-based language. Anytime you can, operate on things as vectors rather than writing explicit code to loop through them. And if not, don't use R, or at least not for that part of the code. You can often get substantial speed up by vectorizing something if you wrote it in a way that doesn't take advantage of vectors. Other than that, there's ad hoc tricks that you can try that might give you a 20 or 30% speed up, but that way will drive you crazy. If you want a order of magnitude speed up, you're not going to get it by just rearranging the R code. If you want that kind of speed up, you probably need to rewrite everything or rewrite a hotspot in some other language. And assuming that you are coming from another language, you're writing Java, you're writing C#, you're writing Python, something like that, and you just want to use a little bit of R for some functionality, you might be surprised by the syntax a little bit of how to use R. So, as I mentioned before, R is a vector language. Everything is a vector. Even if you have a single number, you don't really have numbers in R. You have vectors of length 1. So it's not really strongly typed in that regard. And everything can be null or NA. And as much as I've tried, I still don't really understand the difference between null and NA. Like, one of them is a missing value and the other is a value that's not there. So that's as good explanation as I can find. And people are inconsistent in how they treat this. But the thing to be warned about is everything is potentially null. When you get you receive some R vector back to your program, it's ostensibly a vector of doubles, but don't count on it. One of those doubles might be a null or an NA. Like Fortran, vectors in R are indexed from 1, not from 0, so that's something to look out for. And most bizarre of all, 0 is a legal index in R. It just doesn't do anything, or it's not clear what it does do, but it's legal. It's not like stepping off the end of a C array where you get an uninitialized memory. It's perfectly legal to access the 0th element of an array, and it gives you a type instead of a value or something like that. And you can also have negative indices into an array, but they don't act like you might expect from, say, Perl or Python, where, say, -1 is the last element of an array, -2 is the second to last element. In R, it works completely different. If you have an array and you index -2, that removes the second element of the array. Or if you have a range -2 to -3, that removes the second and third elements of the array. Which may seem like a strange thing to do, but if you think about what R is, I mean, it's designed to be a language for interactive statistical analysis. Well, then, in that context, it makes sense that you might want to remove values. You have outliers, you have missing values that you want to ignore, so it's a common operation to want to remove things. Another similarity between R and Fortran is that by default, matrices are filled by column, not by row. So you can have an R take a vector and interpret it as a matrix by row, but you have to pass in an argument for it to do that. By default, it works on columns, just like Fortran. And some strange syntax. R uses a $sign the way most languages would use a dot, so to indicate elements of a class. Dot is used more like an underscore in C-based languages, just as a conventional separator, but with no language significance. And the underscore used to mean assignment. It doesn't anymore in R. I think it still does in S+, but it used to be that if you had foo_bar, that would assign the value bar to the variable foo, which could be quite a surprise. All right, so on to ways to interact with R. You can always write packages in R that call out to C or Fortran. This is the lowest level interface, and not really one that's recommended anymore. But if you want the most control possible, you could drop down to the C level and deal directly with the innards of R. You have to do a lot of reference counting, memory management, casting. It looks sort of like doing old-style COM programming in C. But these days, most people would use Rcpp, which I'll talk about in a moment, rather than going down to the C level. Rcpp provides a much nicer interface that's as high level as it could be for what it's trying to do. I mean, it still gives you full control, but at a higher syntactic level. Okay, so these days, at least, Rcpp is the most popular way to interact between R and another language. With this, you could call C or C++ or Fortran from R, and you can use even advanced C++. It's fine using STL constructs, templates. There's a rich interface between C++ and R. And if you want to go the opposite direction, you want to call R from C++, you can do that too. It's still part of this Rcpp project, but technically it goes by a different name, R-include. So I'll give an example of this in just a second. You can even inline C++ code in your R. So you have an R script, and then somewhere there's a hotspot, in the core of your program, and you want to make just those few lines into a C function. You can do that still staying in R and just passing the C++ or C or C++ code to Rcpp the way you might write a string of SQL and send it to a database inside a different language. So the main reference for Rcpp is the site rcpp.org. The project was created by Dirk Edelbutel, and he's written a book on Rcpp, so you could find his book from Springer if you wanted to read more about it that way. So here's an example. If you want to use a little bit of C from inside an R program, this is all R code. You load the Rcpp library, then call this function called CPP function with a string. And then the magic happens inside that function that takes that string, interprets it as C or C++ code, compiles it, stores it somewhere, you don't have to know where, and then creates a wrapper around that in R. So then after defining this C++ function called add, I now have an R function called add that's going to be implemented in C++. So it's really seamless if you want to do it this way. And for a small amount of code, this is convenient. If you have a larger amount of code, you probably want to compile some sort of module, call it that way. Or maybe you inline a small amount of code that calls a larger amount of C++ somewhere offline. Now, if you're in the Microsoft world, you're writing .NET code, one way that's been around for a long time is this object called RDCOM. Creates a DCOM interface around R. You could call it from, say, Visual Basic or some COM language, pass it a string of R code, it'll interpret it, run it, and send you the results back. I've used this in production. It's a little scary. There's not much security around that since you can pass it arbitrary code, but we just quarantined that on its own box, and just, it worked. There's a couple of newer ways to interact with R in the Microsoft world. There's the F# type provider, which is especially convenient if you're using F#. If you're not using F#, so you're using C#, you can still use the F# type provider as an intermediary. So you stick in a little F# between your R and your C# code. And there's another project, R.net. I've used RDCOM. I haven't used the F# type provider or R.net. I've heard good things about the F# type provider in particular, but I haven't used that personally. And a new way of interacting with R from the Microsoft world is through SQL Server queries. So recently, Microsoft acquired Revolution Analytics, a company that was commercializing support for R. And Microsoft is in the process of integrating R into some of their products. So you can do things like this now. You can have a bit of SQL code where you actually make R as part of your SQL statement. You're inlining a little bit of R code in the middle of say, a stored procedure. Now, this is kind of bizarre if you think about wanting to connect R and Haskell. If you think about, it's hard to think of two languages that are more different. Haskell is very much emphasis on strong typing, static typing, correctness, no side effects, functional language, and R is everything but that. R is designed for interactive use. And so it's interpreted, it's loosely typed or inconsistently typed, or I don't know what you want to call it. And R is not particularly concerned with the code being correct, in that when there's a trade-off between ease of use and correctness, R is going to be optimized for ease of use. It's designed for somebody interactively exploring a data set. In that context, you're not so worried about type errors. Like, I want the third row of this data set. Well, it is what it is. I'm not going to confuse that for a string or a JPEG image or whatever. You're not concerned about typing, whereas like in Haskell, you really are. Well, I've been on a project where we were wanting to use Haskell and R, which it took me a little while to get my head around, but actually it makes a lot of sense because the languages are complementary. So the project that we were using for interfacing these two languages was Haskell R. It was just called H at the time. Now it's called Haskell R from Twig.io. And the reason we were interested in this was kind of twofold. We wanted to be able to call some R libraries that implemented things that we didn't have on the Haskell side, and also to be able to sort of mix R and Haskell in some of our analysis, being able to call from Haskell into R, and vice versa. And so, this really is a remarkable project to be able to synthesize two languages that are just diametrically opposite. And yet there's deep integration. You can not only pass data between R and Haskell, you can pass functions, like you could write a function in Haskell, pass it to R to optimize it or integrate it or something like that, get the result back into Haskell data types. So there's a deep integration there. And it's all done through this quasi-quoting. You can put your R code inside this Haskell quasi-quote. There's also, as part of the same project, there's a REPL that's a variation of the GHCI REPL where you can interact with R. And you can also use Haskell via Haskell R in a Jupyter notebook, which I'll talk about in a moment. By the way, working with Haskell and R together kind of improved my appreciation for what R is good for. I mean, philosophically, I'm more inclined toward the Haskell school of things. I like static type checking. I like the compiler helping me to make sure my code is correct, etc. And yet, there's some things that were just painful to do in Haskell that were easy to do in R. So when you're doing exploratory analysis, which is what R is good for, you say, I don't care about getting the types right. I just want to see if there's something there first. If there's something there, yes, then we can go back and add all the types and unit tests and like that. But first, I just want to know what's there. And I also don't want to have to change the type of all my functions because I want to insert a print statement. So for that kind of exploratory work, things were much more convenient in R. But then once things were developed and you want to have the assurance that everything is statically typed and no side effects and like that, then it's nice to go back over to the Haskell side. Now, if you're familiar with Emacs org mode, org mode gives you a way of gluing different languages together, including R, but also a lot of other languages. And like all things Emacs, it's kind of crufty. It's a little weird if you're the first time you see it, but it's also very powerful. Again, like a lot of things in Emacs. So it has support for many different languages. You can use org mode to call a little bit of Haskell, a little bit of C or Bash or whatever. You can mix a lot of things together in this sort of markup for org mode. And it works reliably, cross-platform. A lot of things in this talk work, but may not work on the first try. It requires some tweaking, and you got to install things just right and like that. But my experience with Emacs org mode is that it works as documented everywhere on the first try. Now, it may not work as expected, but it does work as documented, and it is well documented. So it's very good for exploring. You know, if you say, okay, I'm working along here, I'm keeping notes on what I'm doing, calling some code, calling this code in Perl, calling this code over here in C. Oh, I need to call a little bit of R, maybe to graph something or whatever. Then you could stick in a little code in R as well. And this org mode is also very good for literate programming. So the idea of literate programming is that you think of your documentation as primary and your code as secondary. So instead of writing your code and then writing a little bit of documentation on the side, you write documentation and inline code as necessary. So you could think of it as commenting taken to an extreme, but it's really more than that. You can reorganize things into the way that's best for a human reader rather than what's best for a compiler. So you might define part of a function here and explain that, and then you might define another part of a function later, and then ask the environment to piece all these things into a coherent thing that the compiler can understand. And I've played with this for a while, and you know, it's fun to play with. Oh, look, I'm calling these different languages, and it's just kind of an interesting toy. But I recently did a project where this really saved my bacon. It was a project where the requirements were very complicated. The code itself wasn't that complicated, but just understanding what needed to be done was where you're most likely to make a mistake. When you're pulling things from obscure sources and saying, I think this means this, it's not entirely clear, but this is why I think this. So to document all that, the literate programming in org mode was really a great way to go. So I'd mentioned that org mode supports a lot of languages. There's a little confusion between org mode and org-babel. The terms are used interchangeably. Technically, org-babel is the library that org mode is using to do all this code management. But there are about 40 languages that org-babel, org mode supports out of the box, and then there's several others that sort of have third-party support but aren't as official as the ones that ship with Emacs. So an org mode file is a form of markup. You can mix text, LaTeX markup, inserting images, inserting links, and so forth. Sort of like HTML, but simpler. And you can also insert code where you have a begin source, end source tag. And at the begin source tag, you tell it what language you're using, and then you just insert that code. And if you're editing this inside Emacs, if you're inside a block of R, you can have the editor enter your R editing mode. So you have the syntax coloring and so forth for R. And then when you're in a section of a different language, then Emacs can edit that as that language, even though it's all in one file. So here's an example. In this one, I'm going to mix together R, Python, and Perl. So I call a sign function. I have a function written in R that just returns the sign. And I called it sign underscore R just to emphasize that it's written in R. That's not necessary. You can call it whatever you want. I just added the suffix to make it clearer where things are coming from. And when you do this, you have to pass in default arguments. So I just said X defaults to 0. Then for my cosine function, I'm going to implement that in Python. And just so I can know that my code works if I, and not just by default, I set the default variable to 1 so that if things don't get initialized, my code will be wrong. So if you notice, in the source block for R, the name of the R language is with a capital R. In the source block for Python, the name of Python is with lowercase p. Most languages in org mode use the program language name in lowercase. For some reason, R doesn't, so it's a capital R. Okay, then moving over to the second column, I'm going to take the square of my two values, because sine squared plus cosine squared should equal 1, right? So I'm going to do this in Perl, just have another language. And then my call statement, the pound plus call, everything in org mode starts with pound plus, just because that's something you're unlikely to type by accident in other code. So in this case, now in the call, I'm calling the Python function, which is then calling the R and the Python. Or so it seems. What's literally going on here is that everything is going through Emacs Lisp. So this is really sort of a hub and spoke architecture where things are going in and out of Emacs Lisp. So the Perl is not literally calling R, but it appears that way. It's being mediated through Emacs Lisp under the hood. And then when you evaluate a code block in org mode, you'll print out the results. So in this case, the result is just a number. The result could be an image. So you're doing something in some other language, but you want to use R for plotting, you could use R to insert an image for a plot. Okay, another way to interoperate languages was Jupyter notebooks. Jupyter started out as IPython, but then they changed the name to de-emphasize Python when there's support for other languages. So the name Jupyter came from the Julia programming language, Python, and R. So Jupyter notebooks are very nice, HTML-based notebook interface to different languages. Supports a lot of different languages separately. So it's not really so much an interop story as a consistent way to implement notebooks in different languages. So you can have a Haskell Jupyter notebook that's using Haskell code, an R Jupyter notebook that's using R, and they're consistent, but they're not actually sharing code that way. So compared to something like the org mode that we talked about, Jupyter notebooks are less transparent for better and for worse. Better because you have more of a WYSIWYG environment. It's sort of like a web-based REPL. So you're interacting with something, you plot something, the plot appears right there, right after where you plot it. You don't see as much detail, which is nice if you're exploring something. Of course, the drawback is since there's more going on under the hood, it's harder to diff the files. They're not just plain text files. You could say, okay, what changed between these versions? Because under the hood, a Jupyter notebook is JSON. It's kind of semi-human readable, and so it's harder to diff than something that's more explicit like org mode. So some of the languages, they're supported by Jupyter kernels. The list is growing every day. There might be a new one since I made this slide. It's really nice. So you have a new language, and you'd like to have this nice notebook support for it. You can just piggyback on what they've already done with Jupyter. Another fork of the IPython notebook is something called Beaker. And this does give more of a language interop story than does Jupyter. So you can mix different languages and pass data between them through this global Beaker object. I'll give an example of that in a second. And one of the nice features about this, if you're dealing with some data set, is that you can pass data frames between languages. So for a long time, one of the advantages of R was that it had this data frame that's kind of like a SQL table, but the columns could be different types, and that just made a lot of data analysis operations more convenient. And for a long time, the story was, yeah, I'd rather write Python, but R has this data frame. Python doesn't have something like that, so I'm going to keep using R. And then Wes McKinney wrote Pandas, this library that that has, among other things, an analog to R's data frame. So what Beaker does is it will translate between these two types of data frame, which is really, there's a lot going on there. This is more than just like converting a string in this language to a string in that language. There's it's more complicated, but it's also very convenient to go between those. There's also the Feather project, Apache Feather, that does the same sort of thing, that has a way of going between R notebook, R data frames and Python data frames. We'll come back to that in just a minute. So here's an example of how you would mix languages using Beaker. So you have different cells in your notebook. In a Python cell, if you want to create a variable foo on the global Beaker object, you say beaker.foo and set it equal to whatever it is. It could be a string, a number, a vector, whatever. Then if you're calling it from another language that uses the same dot convention, you could retrieve the value the same way you set it. So if you're calling from Java, you could have beaker.foo on the right side of an equation. R is a little different, so you have to use this beaker : get function to pull things out of the global object and set to put them back in. So in this case, I have hello world, I stick it into the global Beaker object in Python, then in R, I pull it out, do something with it, say, then I want to create a new global variable, answer, so I can set it in R, then read it back in Python. Now, one quirky thing there at the bottom, I don't say beaker.answer, I say beaker.answer bracket 0, because there are no numbers in R, there's only vectors. So when I set this thing equal to 42, I actually set it to a vector of length 1 containing 42. So that's why I have to read it out as a vector, even though I put it in as a scalar. All right, so some of the different languages supported by Beaker. For our purposes, it has R. That's the one we're talking about today, and it has several of these other nice things. Incidentally, it considers Python 2 and Python 3 to be separate languages. So, all right, and then the final way of mixing R with other languages that I wanted to talk about was R Markdown. So this is more in the spirit of org mode markup. Similar to Jupyter or Beaker notebooks, but it's more text-based. So if you're dealing with Jupyter, you're working in a browser, and there's things that are hidden from you. If you're using R Markdown, you're working in a text editor until you want to export that. So you're working in your text file and say, okay, I'd like to see this as HTML. You export it that way, but you're not working in a browser per se. And like with Beaker, you can exchange data between R and other languages via data frames. And because this is meant for this sort of document-based computing, there are a lot of different ways you can export R Markdown. Different journals have style guides for if you say, here's a R Markdown file that I want to export as a journal article for this journal, you can do that. You can export to LaTeX, export to HTML, and different variations on that. So some of the languages supported by R Markdown. One that may not be familiar is the Stan, the last one on the list. Stan is a language for doing Bayesian analysis, Markov chain, Monte Carlo, and so forth. which is something that's popular in R. So here's an example how you would use R Markdown. To use a language, you just have 3 backticks and then give it the name of the language in braces, and then just write your code and then 3 backticks to end it. So inside the R block, I'm just writing R. Inside the Python block, I'm writing Python. And you can exchange data back and forth between the languages. Not functions as far as I know, but you can exchange data between your blocks using data frames. And just to go back a second, one of the languages supported by R Markdown is Rcpp. So if you have R code in your Markdown file and you want to optimize a bit of it, you can create another block of Rcpp code and call that code from your R code. All right, so in summary, why would you want to mix R and other languages? Typically, you want to call out from R for efficiency, or you want to call into R to grab some functionality. R has a number of differences. If you're wanting to use R, just like you're a Java programmer, you just want to raid R for a few nice things that it'll do for you. A few things to watch out for. There's some quirks. An array of numbers might not all contain numbers, etc. And one thing about most of these approaches is hardly any of them worked on the first attempt. That's just the nature of the beast. Some of these things are a little delicate in how you install them. For most of these, I've had issues where, okay, it works on this computer, but doesn't work on this computer because maybe R is in a little different location and I have to tell it where R is, or the phase of the moon's different or whatever. So I will say a lot of these methods are a little bit finicky and a little bit difficult to set up. We talked about org-babel, and org-babel is the one thing that worked very well on every platform that I tried it on, every computer I tried it on. It worked as documented, but then again, maybe not as expected. But if you do read the documentation, it does work as documented. And in general, the most mature, most powerful way to connect between R and something else is through Rcpp. So if you have a project not written in C++, you can use a foreign function interface to go through Rcpp to R, which is probably the best overall approach. So if you want detailed control over exactly what's going in and out of R, Rcpp is the way to go. If you don't need that, then in some languages you have a higher level interface for going through things. All right, so be sure to rate the session. And if you have any questions, I'll take questions right now. But if you think of a question in a few days that you'd like to ask me, you could email me, or you could check out my website or whatever. There's my contact info. And thank you very much. Okay. So, which language do you prefer to use with R, and for what? So, most of the time, I use Python because it has what I need. R is a statistical language. It's great if you're doing statistics. If you're doing more general programming, you have to do some file munging, you have to create a web service, you have to do this or that. Those kind of things maybe could be done in R, but it's kind of awkward. The thing I like about Python is it's not a bad language for anything that I want to do. Maybe not the best, but it's okay. So I can stay in one language longer if I do that. If the Python is efficient enough. If it's not efficient enough, I usually write C++. In general, I don't try to make Python faster. I don't try to make R faster. If it's not fast enough, I just punt and go write C++, because then I know that'll be faster. Whereas if you're trying to make a scripting language faster, you're going upstream. You're going against the grain. It might work, but you might spend a couple of days trying things and get nowhere. I prefer just not to do that. So that was one question through the app. Other questions live? Good question. So how does this work, production versus exploration? Yes, I have used this in production with a little bit of fear in some cases and not others. So with the Haskell R, we did use that in production. That is, I think that's safe. The people who are developing it know about the quirks of R memory allocation and handling exceptions if something goes wrong. They did a very professional job of integrating those two. And there I could use R in production without hesitation. If you have some R code that somebody gave you, so, okay, here, I've written this R code. All you need to do is put a web interface on top of it. I would be afraid of that no matter what tool you're using, because people who are writing R for their own use don't think about how things are going to run on a server. There could print statements. There could be something where they're expecting somebody to enter something or whatever. It's just not ready for a production environment. I've used the RDCOM thing in production. Again, with a little bit of fear and trembling, but we did. We quarantined it on its own server and used that in production. Most of these other things would be more for interactive exploration. I guess somebody could use Emacs in production to glue things together. That would be kind of strange, but maybe you could do it. Yes, sir. Okay, yeah. So the question is, tools to translate R to JavaScript so you could run it in a browser. I don't know about that, but RStudio has a project called Shiny that will let you develop interactive web pages using R. Yeah. By the way, I had a quote from Hadley Wickham. I meant to say more about Hadley. He's now at RStudio. If you're going to use R, seriously, look up Hadley Wickham and his website and all of his tools. He's written some fantastic code that protects you from some of the weirdness of R. He's written a lot of really useful tools that let you kind of work at a higher level. Other questions? All right. Well, if you think of something later, shoot me an email. I'll be glad to answer it later if I can. All right. Thanks.